So obviously this is a part of matrices in a mathematical physics. So Alok sir will discuss it in a very nice way in a mathematical physics. But I am just trying to talk all these eigenvalue and eigenvectors from the quantum mechanics point of view. Okay, so let's try to uh, define what is eigenvalue and eigenvector of matrices. So here, so suppose I have a vector, and if it is going to operate on a matrix, and it is going to operate on any phi I, and if you are getting this proportional to same phi I, so operating on phi I, you are getting the same vector. Okay, so if you have this sort of information, then obviously there is some proportionality constant, and I can write this a phi I is equal to something lambda I phi I. And if you have this sort of information and this lambda I, it's some constant. So in quantum mechanics, if I am talking about constant, this can be imaginary number also. So if I have a operating on phi I, what I am getting lambda I phi I. Then this is a very interesting equation, and this is basically eigenvalue eigenvector equation. Okay, so this is particularly, so this vector is identified as eigenvector, and this number is identified as eigenvalue. Now we can write the whole thing something like this: a minus lambda I into phi I is equal to 0. If A is matrix, then this is identity matrix. Lambda into I is identity matrix phi I. And what we have either phi I could not be equal to 0. So this should not be the null matrix. Phi I should be some matrix except null matrix. Then we have a minus lambda I must be equal to 0. And this is determinant of a minus lambda I must be equal to 0, which is very popularly known as characteristic equation or secular equation. Okay, so you can say this is secular equation or characteristic equation. So this is your secular equation or characteristic equation. And what you can get, you can a minus lambda I is equal to 0, and this is determinant. So you can solve this equation and you can get the value of lambda. And this lambda is eigenvalue. You can write lambda I or lambda in general way. That is your eigenvalues. So if A is n cross n matrix, if A is n cross n matrix, there should be n number of eigenvalue. There should be n number of eigenvalue. If eigenvalues are non-repeated, they are said to be non-degenerate eigenvalue. They are said to be non-degenerate eigenvalue. And if they are repeated, So I have to just clean. I can use this part. Huh? So if eigenvalue is repeated, they are said to be degenerate eigenvalue. So suppose you have lambda 1, lambda 1, lambda 2. So lambda 1 is what? Repeated. So they are doubly degenerate. Okay, you can have 0, 0, 1. So 0 is what? Doubly degenerate for 3 cross 3 matrix. So these are what? Degenerate. So this is degenerate. And this is what? Non-degenerate. Okay. So this is what? Non-degenerate. Now, in quantum mechanics, what we have to do in general. So यहां तक क्लियर है ना? अभी इस पर प्रॉब्लम करेंगे तो और भी ज्यादा क्लियर होगा. डोंट वरी. ठीक है? In quantum mechanics, one and sorry. First, we have to define eigenvectors. Okay. So suppose for lambda is equal to some lambda I, if A is going to satisfy the equation phi I, any vector, and this is some vector, if phi I is any vector which is going to satisfy the equation, lambda I, phi I, then phi I is said to be eigenstate, said to be eigenstate or eigenvector, eigenstate or eigenvector corresponding to. So look at the language. Language is very interesting. So phi I is the eigenvector corresponding to. So phi is the eigenvector corresponds to eigenvalue lambda I. So, but the thing is that in quantum mechanics, in general, your eigenvalues or your eigenvector or eigenstate may be orthogonal, may not be orthogonal in a mathematically, but in quantum mechanics, we try to figure it out always orthonormal eigenvectors. So in quantum mechanics, we try to find orthonormal eigenvector. We try to find orthonormal eigenvector such that they can make complete basis. Okay. So this is a real challenge in a quantum mechanics. Okay. So let's try to do some problem and then finally I will give you conclusion. Okay. So first I will just try to solve one problem and after that I will give you some homework to you, and tomorrow I will discuss in a very deep manner what I want to tell all about this particular eigenvalue and eigenvectors. Basic mainly orthonormal eigenvalue and eigenvector. So suppose I have a matrix and this matrix is 0, 1, 1, 0. So this matrix is what? 0, 1, 1, 0. Suppose this is my matrix A. And I just want to calculate eigenvalue and eigenvector for this particular matrix. So first we have to write the characteristic equation. And what is this characteristic equation? A minus lambda I must be equal to 0. So you can write A is 0, 1, 1, 0 minus lambda. What is I? Is the identity operator. So obviously if it is 2 cross 2 matrix, then I is also 2 cross 2 matrix. That must be 0. And we have to make a determinant. So minus lambda. Sorry, that is, yes, minus lambda 1, 1 minus lambda must be equal to 0. Up to that, everyone is comfortable? And now what we have to do? We have to solve this determinant. Okay. So what is this value? This value is minus plus lambda square minus 1 must be equal to 0 and lambda is equal to plus minus 1. So I can say lambda 1 is equal to plus 1, lambda 2 is equal to minus 1. So they are degenerate or non-degenerate? Non-degenerate.
Non-degenerate.
So eigenvalues are what? Non-degenerate in nature. Okay. So these are non-degenerate. So what we have to do? We have to calculate the eigenvectors. Okay. So let's say lambda 1 is equal to 1, phi 1. What is phi 1? Phi 1 is some sort of column matrix, isn't it?
Yes.
And that can be defined as, let's say, A1, A2. And I have to calculate the value of A1, A2, which will satisfy the equation. And what is this equation? This equation A phi 1 is equal to lambda 1 phi 1. And what is this A? 0, 1, 1, 0. And here is phi 1. What is this particular phi 1? A1, A2. And what is your lambda 1? Is 1. You have A1, A2. And what you will get? You will get the answer. What is this value? क्या हो जाएगा यहाँ से? A2 is equal to A1 or A1 is equal to A2. Are you comfortable? Everyone?
Yes, sir.
Okay. So you can just multiply 0 into A1, 0, 1 into A2, A2. So A2 is here. And you are equating the same row. Okay. So what is your phi 1? Your nature of phi 1 is A1 and A1. How many vectors you can make something like A1 and A1?
Infinite.
Infinite number of vectors you can make when you are getting A1 and A1. 1, 1, 2, 2, 3, 3, I, 10, 10. Yes, you can make infinite vectors. But is that all vectors are normalized?
No, sir.
No. So is that all vectors are parallel vector?
Yes, sir.
Yes. All vectors are parallel vector. 1, 1, 2, 2, all are parallel vectors. So can I represent all parallel vector in a form of one normalized vector?
Yes.
हर एक पैरेलल वेक्टर का नॉर्मलाइजेशन कांस्टेंट क्या होगा? सेम होगा ना? है ना? नॉर्मलाइजेशन कांस्टेंट की मैं बात कर रहा हूं, है ना? So I can normalize it. So what? How you will normalize it? Phi 1 is equal to 1. So you have A1 star, A1 star. You have A1 is equal to 1. So that is your 2 times mod A1 square is equal to 1. So A1 we will get 1 by root 2. So what is your first eigenvector? So lambda 1 is equal to 1. The eigenvector phi 1 is equal to 1 by root 2, 1 and 1. Okay. Now let's try to go for, and this is your normalized vector, isn't it? This is your normalized vector. Are you people comfortable?
Yes, sir.
Yes, sir.
Okay. Let's try to go for a eigenvalue corresponds to lambda is equal to -1. निकालें क्या? चलो. This is just very simple thing, but it is very important such that you can do practice. So you have a lambda 2, sorry, क्या लिख रहा हूं? A phi 2 is equal to lambda 2 phi 2. And what is your value of phi 2? I can assume your phi 2 is equal to, let's say, B1, B2. This is your phi 2. Okay. And now, if you are getting B1, B2, so you have to find the suitable value of B1 and B2. So you have 0, 1, 1, 0. And what is your phi 2? Is B1, B2. And what is your lambda 2? -1, B1, B2. So what you are getting? You are getting B2 is equal to 0 into B1, 0. 1 into B2 is B2.
Minus B1.
B2 is equal to minus B1. And similarly, B1 is equal to minus B2. Both are same thing, isn't it? So again, I can write phi 2 is equal to B1 minus B1. Can I write? Or you can write minus B1, B1 also. That is the same thing. Not any problem. So how many vector you can get B1 and minus B1? Something like B1 and minus B1?
Infinite.
Infinite number of vector. But all these vectors are parallel vector. 1 minus 1, 2 minus 2, 3 minus 3, 100 minus 100, I minus I, all are parallel vectors. Okay. We can represent all these parallel vector with some unit vector. At least in a direction sense, we can represent them as a unit vector. So I have to normalize it. So when we are going to normalize it, that is phi 2 is equal to 1. So you have B1 star minus B1 star, and you have B1 is equal to 1, and you can get B1 is equal to again 1 by root 2. Yes. And now you can check lambda 2 is equal to -1, phi 2 is equal to 1 by root 2, 1 minus 1. Phi 2 is equal to 1 by root 2, 1 minus 1. Now, just check whether these two vectors are orthogonal or not. These two vectors are orthogonal or not? Just check.
Yes, sir, orthogonal.
These two vectors are what? Orthogonal in nature. So what you are saying, you are just watching phi 1, phi 2, and that is 0, isn't it? You can take 1, 1, 1 minus 1, that will be 0. So this is your orthogonal vector. So you can see if your eigenvalues are non-degenerate, you can easily you can find a set of orthogonal vectors, and that is unique set. इसके अलावा और कोई वेक्टर ऑर्थोगोनल मिल रहा है क्या?
No.
मेनली ऑर्थोनॉर्मल वेक्टर्स. क्या इसके अलावा और कोई ऑर्थोनॉर्मल वेक्टर मिलेगा क्या आपको?
No, sir.
नो.
पैरेलल टर्म से वो तो
ऑर्थोनॉर्मल मींस नॉर्मलाइज है तब तो यही वेक्टर मिलेगा ना.
यस सर.
So we can make a statement, and this statement is very interesting. And what is this statement? This is very interesting. Just a minute. Now, if eigen value of operator is non-degenerate, then one can find unique set of orthonormal vectors. मीन्स एक ही सेट मिलेगा आपको ऑर्थोनॉर्मल वेक्टर का, अगर ये आपके आइगन वैल्यूज क्या है, नॉन डिजेनरेट है. एंड यस, यू कैन इजिली फाइंड दे विल ऑल्सो मेक व्हाट, कंप्लीट बेसिस. आप देख सकते हो कि ये कंप्लीट बेसिस बनाएंगे. यू कैन इजिली चेक. लेट्स चेक phi 1 प्लस phi 2.
आइडेंटिटी आ रहा है.
phi 2 देखो आइडेंटिटी आ रहा है क्या? 1 by
sir.
root 2, 1 by root 2. You can have 1 by root 2, 1 by root 2 plus 1 by root 2 minus 1 by root 2, and you have 1 by root 2 minus 1 by root 2. What you will get? This is half, 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 half. Second term is half minus half minus half, half, and you will get 1, 0, 0, 1. So yes, they can be treated as a complete basis. है ना? Yes, everyone is going to understand this thing.
सर यूनिक ऑर्थोनॉर्मल बेसिस मिलेगा और ऑर्थोगोनल भी यूनिक ही होगा ना, मतलब ऐसा कुछ
ऑर्थोनॉर्मल बेसिस मतलब क्या है? मैं समझ नहीं रहा हूं, आप पूछना क्या चाह रहे हो?
मतलब यहाँ हमने लिखा है ना कि अ सेट ऑफ ऑर्थोनॉर्मल,
एक ही सेट मिलेगा ऑर्थोनॉर्मल बेसिस का, अगर मिलता है तो.
वैसे ऑर्थोगोनल भी एक ही सेट.
अरे भैया, ऑर्थोनॉर्मल हो गया तो ऑर्थोगोनल तो हो ही गया ना. नॉर्मलाइज तो आपका चॉइस है, जब चाहो तो नॉर्मलाइज कर दो वेक्टर को, अगर वो नॉर्मलाइजेबल है तो. आर यू गेटिंग माई पॉइंट? भाई नॉर्मलाइज करना तो बहुत इजी चीज है. अगर इफ योर वेक्टर इज नॉर्मलाइजेबल, यू कैन इजिली नॉर्मलाइज इट.
ओके सर.
है ना? द थिंग इज दैट यू आर गेटिंग यूनिक सेट ऑफ ऑर्थोगोनल वेक्टर्स. एक ही सेट मिलेगा आपको ऑर्थोगोनल वेक्टर्स का, अगर ऑर्थोगोनल वेक्टर मिलता है तो. मे बी देयर मे बी चांस दैट यू आर नॉट गेटिंग ऑलवेज ऑर्थोगोनल वेक्टर्स, है ना? बट इफ यू आर गेटिंग ऑर्थोगोनल वेक्टर्स and if your eigenvalue is non-degenerate, then you can find a unique set of orthogonal vectors. Clear है ना? Now let's try to go for second example, that is dangerous example. Okay, why? Let's try to go for this. यहां तक clear है ना?
एक्सक्यूज मी सर.
हाँ बोलो.
सर अगर हमें आइगन वेक्टर नॉन डिजनरेट वैल्यूज देता है तो इसका मतलब वो हमेशा मतलब कंप्लीट बेसिस मिलेगा या चेक करना पड़ता है?
हाँ, वेरी गुड, वेरी गुड, वेरी गुड. अभी देखते हैं, उसी प्रॉब्लम पर तो आ रहा है, बिल्कुल उसी प्रॉब्लम पर आ रहा है. ठीक है, डिजेनरेट आइगन वैल्यू आता है, फिर देखते हैं क्या होता है. ठीक है,
ओके सर.
है ना? वही तो रियल चैलेंज है. वेरी गुड, आप सही जगह पर फोकस किए. गुड. चलो, और मैं आपको बिल्कुल ही एक पॉइंट पर छोड़ूंगा और मैं चाहूंगा कि आप उसको सॉल्व करके मुझे पोस्ट करो, बट पहले मैं कुछ चीजें देख रहा हूं. So let's say my matrix is 1 0 0 0 0 1 0 1 0. So this is what 3 cross 3 matrix. Yes. So how many eigenvalues you have to calculate?
3.
3 eigenvalues इसके मिलेंगे, है ना? So let's calculate the characteristic equation. A minus lambda I must be equal to what? 0. Yes. And if you are going to write it 1 minus lambda 0 0 0 minus lambda 1 0 1 minus lambda, and this must be equal to 0. Now you have to expand about this point or this particular element. So 1 minus lambda, you have minus lambda whole square minus 1 must be 0. So 1 minus lambda, lambda square minus 1 must be equal to 0. So what you are getting? So first is 1 minus lambda is equal to 0. So from here lambda is equal to 1. And second is lambda square minus 1. Sorry, कुछ गलत लिखा हूं क्या?
सही है सर, आ रहा है टीचर.
सही है सर, यही टर्म बचेगी, बाकी सब तो जीरो हो जाएगी.
Okay, ठीक है, ठीक. हाँ, okay. And then lambda is equal to 1 and lambda is equal to minus 1. है ना? मैं कुछ और समझ लिया था. चलो, lambda is equal to 1, lambda is equal to minus 1. यही तीन मिल रहा है ना? Now, what is your ortho? What are the eigenvalues? So let's say lambda 1 is equal to minus 1. है ना? And lambda 2 is equal to 1 and lambda 3 is equal to also 1. Are you people happy?
Yes, sir.
So lambda 1 is equal to minus 1 is degenerate or non-degenerate?
Non-degenerate.
Non-degenerate. Very good. So this is what? Non-degenerate. And lambda 2 is equal to lambda 3. That is what? Doubly degenerate because it is repeated twice. So this is doubly degenerate. Okay. So what I am going to do, I am just going to calculate the eigenvector first for lambda 1 is equal to minus 1. So this is degenerate or non-degenerate? Non-degenerate. So what you will get? 1 0 0 0 0 1 0 1 0, and let's say this A pi 1 is equal to lambda 1 pi 1. So I can choose my phi 1 as, let's say, A1, A2, A3. So I can put A1, A2, A3 is equal to 1. Sorry, minus 1. That is lambda 1 is equal to minus 1. I am getting A1, A2, A3. So can I solve this equation? What will be this value? बताओ पहला इक्वेशन क्या हो जाएगा?
A1 is equal to minus A1.
A1 is equal to minus A1. दूसरा इक्वेशन?
A3 is equals to
A3.
minus A2.
Very good. A3 is equal to minus A2. तीसरा इक्वेशन?
A2 is equals to minus A3.
A2 is equal to minus A3. Very good. What is meaning of A1 is equal to minus A1?
A1 is equal to 0.
That is 0. Only one thing can be happen when A1 is equal to minus A1. That means 0. A1 must be 0. So here I am getting A1 is equal to 0. And these two equations are same equation?
Yes, sir.
Yes.
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 So what is the nature of my phi 1 vector? So I am just removing this thing. The nature of my phi 1 vector is something like 0, A2 and minus A2. Yes or no?
Yes, sir.
Yes,
And now how many vectors you can write in this form?
Infinite.
infinite vectors, and an infinite number of vector you can write in this form. But all vectors are what? Parallel to each other?
Yes, sir.
Yes.
Yes.
Yes, sir.
So what you have to do? So avoid the parallelity, you have to make it what? Normalized. है ना? So I can write phi1 is equal to 1. What will be normalization constant? 0, A2 star minus A2 star, 0, A2 must be equal to 1. So 2 times A2 square, and you can take mod A2 square is equal to 1. So A2 is equal to 1 by root 2. So for lambda 1 is equal to minus 1, phi 1 is equal to 1 by root 2, 0, 1, minus 1. Okay? Now, the real challenge will come to find the eigenvector lambda 2 and lambda 3. So I am just giving you homework. Find the eigenvector for lambda 2 is equal to lambda 3 is equal to 1. And you have to make sure that these eigenvector must be orthonormal. Normalize तो आप कर लोगे, लेकिन चैलेंज क्या होगा?
Orthogonal.
ऑर्थोगोनलिटी. देखें आप क्या करते हो. Just try to do this thing. I will continue tomorrow, but मैं चाहता हूं कि आप इस पर माइंड स्ट्रॉमिंग करो. Take your time. Try to solve it. एक क्वेश्चन सॉल्व कर लोगे, आपका एक क्वेश्चन मैथमेटिकल फिजिक्स से भी क्लियर हो जाएगा और क्वांटम मैकेनिक्स के कॉन्सेप्ट तो अच्छे हो ही जाएंगे. So this is a very important point where I am concluding this class. ठीक है, कल की क्लास में मैं इसी चीज को लेकर के आपके सामने आगे बढ़ूंगा. फिर आप सोचोगे कि एक्चुअली क्या हो रहा है और क्या हमें करना है. Are you getting my point?
Yes.
है ना? So कल पहले मैं इस प्रॉब्लम को पूरा करूंगा, and then we will solve some problem based on operators, and then we will go for the last mathematical tool, that is probability density. Okay? Thank you.
Thank you, sir.
Thank you, sir.